Hello.
Hi.
Hey, hearing okay?
Yep.
Hello, Dr. Kim.
Hey. Okay, last week we stopped here, I believe. Multi-product break-even analysis. Example, Le Bistro, like most other restaurants, makes more than one product and would like to know is break-even point in dollars. Information for Le Bistro follows, and the fixed cost are $3,000 per month. 3 product: sandwich, drink, and baked potato. And the annual forecast sale units 9,000, 9,000, and 7,000. And price $5, $1.50, and $2. And then this is a variable cost. So $3, 50 cents, and $1. To get a multi-product break-even point, we need this formula. So fixed cost divided by, this is like another single product break-even point. This is like a price minus variable cost, this part, because it's multiple product, so we need a sum of. So to get this one minus variable cost divided by price. And then this part is like a contribution, like margin. And then times that is the kind of weight among those products. So to get this one, we cannot get numbers right away. So we use kind of a table like this. So annual forecast sales 9,000, 9,000, 7,000. Sales price, and then variable cost. Then we need variable cost divided by price, and then one minus that one. So this is a contribution, and then annual forecast sales. That is from multiply this one and this one, and then percentage of sales. So total each sales divided by total sales, and then this is weight. So using the table, and then we can get numbers, this one, and then we can get this one like this. So I will show you using Excel how to do get this break-even point for multi-product. So the file is, by the way, a moment ago I went to the Applebee restaurant menu because my wife a moment ago called me and then bring food for dinner. So I searched what I should order. Then I put some food in what do you call that? The order kind of box. Then when I finish, then I click to save time. Okay.
So you're hungry?
I'm not hungry now. I'm not hungry now because I have two classes Monday, Wednesday. So at 4 and then at 6. So I have some time like 40 minutes, 50 minutes sometimes. So I stay at my car. I don't go in the office because office is inside. So I stay in my car, then drink coffee and then a snack. So I'm not hungry now, but when I get home, then maybe I'm hungry. Okay, you can download the file supplement 6 and 7 and hi. This one supplement 7 example. I will open this one. Okay, open. I'm not sure why when I use this laptop at home, slow, but at school, a little bit faster than, still slow, but then a little bit faster than at home. Okay, I made a tablet like this. So for a table, I made like this. So annual forecast, how many, and then price. By the way, you can see, right? Okay. And then variable cost. So this column, you need a variable cost divided by price. So variable cost here, and then price here. So it's simple. Type equal sign, and then variable cost. Click and divide by price, and then enter 0.6. Then you cannot copy this cell all the way down like this and like this. I like change decimal point, maybe 2 decimal point, not enough. And then this part, contribution, 1 minus this rate. This is like a variable cost portion against the price. So 1 minus this variable cost portion is contribution or margin. So that will be equal 1 minus and this part. Enter. And the same copy all the way down. I'm choking. not coughing. And annual forecast sales, that is sales price times the annual forecast sales. So this one equals price times, where is the time? Okay, times and forecast equals, and then copy down. And then a percentage of the sales kind of weight. So we need a total. So total equals sum of this part, three parts. Okay, then percentage of sales equals each sales divided by total. So equals each sale divided by total sale. We will use this cell again and again for other cells. So make it absolute value or absolute reference by typing F for function. Where is the function key here? Then it changed $G$9. So $sign means that cell is an absolute. So use that cell again and again. And then type. Then copy down. I need change 3-digit decimal. Okay, decimal point. Okay. And then weight of each one. So that is column 6 times column 8. So percentage of sales times the contribution. So equals column 6 times column 8 and enter. Uh-oh. It should be not so without a dollar, it's not the money percentage rate. So change general and like this. So this one is each product, this part. So we need a sum of, so equals, you can use a function for this one, or already we did it here. So without using a function, just copy all the way to the right. This one is not a dollar. So weight, percentage of sales, total is should be 1. This is right. And this one, okay, 3 decimal points. So textbook use calculation and then round up and then 0.47, but this one 0.469. And then here, this break even point in dollar. That is this one. So it will be equals fixed cost. Monthly fixed cost is 3,000, and then this is yearly, so times 12. So 3,000 times 12 months. That is total fixed cost divided by this bottom part. Denominator part is this one. the price minus the variable cost part. So click this one and enter. So break-even point is $76,000, about $76,764. But forecasting expected annual sales is 72,500. So this is less than a break-even point. So what do you think? Break-even point is higher than the annual sales. To make it a profit, either way, like too much fixed cost. So reduce fixed cost or decrease variable cost. And one more way, increase sales. To increase sales, how much this restaurant sell daily? If we assume this restaurant open 6 days per week, then 52 weeks. So how many days? If we calculate like a daily sales to make a profit, like a daily sales break-even point equals this break-even point dollar divided by how many days? That is 6 days open, then times 52 weeks. Daily sales break-even point is $246. So to make profit, first way, decrease fixed cost. Maybe second way is decrease reduce variable cost by cheaper ingredient or something. One more, increase sales price, then profit increase, and then increase sales itself using commercials and coupon and so on like that. So using this break-even point, we can make a kind of strategic decision. So this is people say insight using calculation or analysis, find something, get insight, and then using that insight, we can decide decision making. Okay. Always I feel sorry when I give you assignment. But there is an assignment, similar one here. So open this one, then you will have 2 files, question file and Excel file. I made a create table like that. So try, okay? Due is next Tuesday. Okay, if you don't have a question, then I will go next part. Today's lecture, chapter 16 and 17. Okay. Chapter 16 about JIT and lean operations. JIT, just in time. Just in time. JIT, an approach for continuous and first the problem solving by focus on throughput and reduced inventory. Problem solving, what kind of problem? Maybe we will talk about that problem later. Many problems. And identifying problems, again, problems, and driving out waste, reduce costs and variability, and improve throughput. So identify and solve the problem to reduce or eliminate waste, to reduce costs, and then the variability, and improve the throughput. That means increase the productivity. And then this one is an integrated set of activities designed to achieve high volume, increase throughput or production rate. Then using minimal inventory. So use minimal, reduce inventory. And then the JIT system is make to order system. So nothing will be produced until it is needed. So don't act until a customer place order, then start. That is a pull system. Pull system, inventories are pulled through the system by actual demand, make to order system. So when a customer place order, then the system starts to make. I will show you why it is pull system. Use color. Blue. Okay, when a customer place order, and then this final assembly part doesn't have a final product. So ask part, ask part, ask part, then ask part, like this. So asking is give me like that, right? So inventory or part pulled by order, right? So this JIT system is make to order system, and pull system. Okay. And the other side, push system. Demand is forecasted, and then by that forecast, just make. So make to stock system, conventional or traditional system is make to stock system. MRP system is, we'll talk about MRP later. So MRP system, traditional system, they are make to stock system, and then push system. Why it is push system? By forecasting, they know like a due date. So just make and then push down, make and push down, make, push down, and so on like that. So make to stock system is a push system, just make and then push down to downstream. So that is the push system. But anyway, JIT system is a pull system and make to order system. Okay, in JIT system, lean operations, there are three important fundamentals issue: waste, variability, throughput. That is like a output. Actually, throughput means like a total the time, throughput time. Okay, first, waste in anything is anything that does not add value. From the customer point of view, maybe the production point of view too. So waste, what kind of waste? Overproduction. So demand is like 1,000, but produce 2,000. What happened? Inventory, unnecessary inventory space, unnecessary time, unnecessary cost, and so on. So overproduction. And queues, kind of waiting time. Maybe order part, the supplier send late, so wait, so waiting time. That also waste. And transportation, long transportation. Bring part from if our plant is in Scranton, then parts companies in China, then it takes long. So long transportation also kind of waste because it's time. Inventory, again, unnecessary inventory by overproduction, that also waste. And then unnecessary motion, that also waste. And overprocessing. You know, earlier we talked about the design. Then if making a product like a 100 part and then 50 parts, then 100 part need more the process and then more time, and then increase the chance of defect. So many things. So unnecessary motion also waste. I mean over processing. And the defective product, the quality, low quality can be a waste. So they are waste in JIT system, every system. And then variability. Last time we talked about in supplement 6, the control chart. So variability, variation. So depart from the mean or designated specification. That is also variability. So poor source of variability, poor process resulting in improper qualities and late non-conforming units. So because of this variability, improper quantities, over process, over product, unnecessary things, so waste. So variability increase waste. And then inadequate maintenance. We will talk about maintenance later this chapter. So because of inadequate maintenance, malfunction, break down the machine, then need fixed time and cost and so on. And then unknown and changing customer demand. Customer demand fluctuate, then it's harder to match that. Then we need inventory, safety stock, and so on. And incomplete or inaccurate drawings. So maybe it's like an improper instruction or specification, and then a bill of material. The bill of material is the structure of the product, so improper like design, then cause of the variability. And then variability, if there are unnecessary high inventory, then the cause of the variability or variability itself, we cannot find it easily. Harder to find that variability because we have inventory. But low inventory level, then we can see the variability. So less variability result in less waste. So try to make it less variability in or any system. And throughput is total time to produce. So from ordering a lead time, ordering a part from a supplier, start from that time to finish the product. So many times, like cycle time, run time, waiting time, setup time, and so on. So try to reduce all time. So each waste minute, products are in the process cost accumulate and comparative advantage is lost. So waste make comparative lost. And then poor system increase throughput. Poor system sometimes because we don't have a part, so order and then pull, wait like that. So sometimes the pull system increase the throughput time. And then pulling material in small lot, inventory cushion are removed. So we'll talk about this in a small lot later again. Anyway, just in time system use try to use a small lot to reduce inventory. The manufacturing cycle time is reduced. Reduce the cycle time. The cycle time is the average time to complete one and so on. And push system dump orders on the downstream stations regardless of the push system just make the send down. So sometimes they make an increase the inventory, and then sometimes. So either way, if we don't use properly a pull system or push system, then waste increase. So in JIT system, use such concept and techniques and technology, then something result, then that comes to like make it better, cheaper, faster, then achieve the comparative advantage. Okay, the most famous JIT system is Toyota system because Toyota system started this JIT system and then still used that JIT system. So they called Toyota JIT system as TPS, Toyota Production System. So in Toyota Production System, JIT system, Toyota tried to identify and solve the problem continuously, and then try to eliminate unnecessary things, problems, by eliminate waste. Okay, first concept, focused factory networks. Focused factory networks. These are small specialized plants that limit the range of products we produce. Sometimes only one type of product for an entire facility. Because I have not visit Toyota plant, but I visit Hyundai and Kia in Alabama and Georgia, and then I know about that. So in Alabama and Georgia, I will draw a map. So this is Alabama and Georgia border, and then about here, Montgomery, and then Atlanta here. So, and then this is I-85. Then from north, I-65. And then Hyundai is about here. It's actually Montgomery area like this. And then Kia is about here. And then near Hyundai, there are many suppliers. Then also near Kia, like here Kia, and then here Hyundai. And then along this I-85 suppliers lined like this. So they are for Hyundai and Kia. Yes. And then most of them for Hyundai, and then most of them for Kia. So they are suppliers for Hyundai. And then one of these companies, this one, name of that company was Korean name, Pyeonghwa. And then one of this one is Ihwa, H. So this Pyeonghwa company produce the circuit in the door panel, the switch, the door, the window up and down, and then the control the panel there. So inside of the door panel, circuit board. So this company produce that one and then send to Ihwa, and then this Ihwa plant produce the door panel. So Ihwa received the circuit from Pyeonghwa and then assemble and then send it to the Hyundai. So this company name is Daehan. This company produced the instrument, the mileage, and so this one sent to a certain company. That company produced the dashboard, the assemble, and then send it to them. So those companies produce one item, like a circuit board, door panel, and a dashboard, and instrument panel, and so on like that. They are focused factories, focused factories, and then they connect each other, and then connect to Hyundai like this. So it looks like a network, right? So this is focused factory network. What is benefit of this one? Earlier, the cause of waste, the time, transportation. So they place near the main company to reduce the transportation distance and time. So using focus factory network, Toyota, Hyundai, Kia, any like Volkswagen, GM. So in Detroit area, the same. Main company, and then suppliers near that. So that is focused network, factory network, to reduce whatever unnecessary time. So using this one, Toyota, and then other companies reduce time. And then group technology, using group technology, similar part, grouped in the similar part or similar process, grouping, and then make a cell like this. And then before using group technology, usually using the functional layout, but grouping the similar, and then make a cell, and then reduce distance, and then make it simple, the path. Then using group technology, companies can reduce time and then distance and so on, waste. And then quality at the source. That is inspection at the source. So without this one, usually companies receive the part from a supplier, then inspect. Then it is okay, and then produce. And then after done, they inspect again. So kind of redundant. So ask suppliers, inspect themselves, and then make 100% sure, then send. Then trust the suppliers, then without inspection, produce right away. So reduce time, throughput time. So using statistical process control, we talked about that earlier, the empower employees. This one, maintenance, talk about this one in maintenance, empower employees. Just let them let them solve the problem themselves. Then without, if they have like authorization empowered, then they can handle everything. Then they don't need to ask, oh, we need this, then ask, and then wait, and then solve the problem and so on. So there is time. And then fail-safe method, using fail-safe method. Did we cover that one in quality? Yeah. So using a fail-safe method, then expose poor quality with a small loss. So using a smaller size in a JIT system. So if they use a smaller size, then they can identify the poor quality easy, and then provide immediate feedback. So when they need, then feedback immediately without so reduce waiting time. And then uniform plant loading. Uniform plant loading in Japanese heijunka. So it's like when they schedule a firm monthly production plan. First month, like level scheduling. First month, 100. Second month, like 150. And then third month, like 50. Then this company need 150 capacity. So this is waste, and this is waste. So using level scheduling and then from a monthly production plan, level like 100, 100, 100. And then this company need only 100 capacity like this. Technically. So this company can reduce unnecessary 50, unnecessary. Technically, I have the kind of the story about the technically. A few years ago, I went to Myrtle Beach because I like to play golf. Actually, I didn't need to go Myrtle Beach at that time because I lived in Alabama. So Myrtle Beach was colder than Alabama earlier. But one of my friends live in Baltimore, and then he's asking me meet because it's like Baltimore there, and then Alabama here, then Myrtle Beach here. So it's like the same distance. So we went there, and then before I went there, booked an hotel room, and then hotel room description like a ocean view, ocean front, mountain view like this. So I ocean front in the room was very expensive. So ocean view, okay, click, and then I reserved ocean view room. So he arrived and then check in, and then went to the room. Then the window outside building is a building view. So I went down to the desk and then asked, I reserved the ocean view room. Ah, yeah, that is ocean view. No, only in the building. I can see all the building. Go out to the balcony terrace. Then you can see the ocean. Technically, that room is ocean view. Okay. So technically, we need that. Okay. And next thing is Kanban production control system. Kanban means sign. Kanban is Japanese. And then also in Korean, similar pronunciation, Kanban and Kanban. Kanban means sign. Then you go on Walmart, then you can see the sign, Walmart. That is Kanban. Kanban sign using instruction card, container, Kanban square, colored golf ball, whatever ball, to signal the need for production of parts. So when they need send the signal using a container or using certain sign, so it's like, you know what, when we talked about process, then buffer, it's like a buffer. Looks like this, then I will draw it again. Between two stages works using two Kanban containers, and then they, when they start, the parts are full like this, at least one container. Then this one use this part, and then when it's empty, then there is maybe it's a sensor, and then send the signal. I need a part. Then this one, fill the container. Then this one use this one, and then signal send, and then fill it like this. So this is in Kanban. At my home, I use this Kanban system. You know what? I will draw something. What looks like water dispenser, the 5-gallon of water, then cold and hot water. So I go market, Walmart, and bring a full water, 5-gallon, two of them, and then one up there. So when it's empty, here empty bottle. If there are two empty bottles, that is sign of go to Walmart. So I use the Kanban system at home. So what is benefit? Never out of parts like this. So reduce waiting time or eliminate waiting time using by using a Kanban system. Okay, next one. Minimize setup time. Setup time is unnecessary time. If they can reduce. Setup time, if they produce multiple types of products, then each product come in, and then by the way, use one line, then change the process, change the equipment, and so on. That is setup time. So try to use, try to reduce setup time. You know, earlier, Hyundai used this. Still, they use only one production line, and then produce two types of product, and then each type has some different part and color and so on. So earlier, Hyundai, one of many of them I know. Like on Saturday night, they go to plant. That means they need to change the process. But later, they didn't do that. They use a new system. Still use only one line. Then type A come, type B come, like in the Hyundai Sonata and the Hyundai Elantra come in. Then earlier they changed this, Hyundai changed this in the process in one night, and then produce Sonata, and so on, and then sometimes later the Elantra like that. But they mix like earlier, like a 1000 A, 1000 B, and so on. But later, Hyundai produced like A, B, two of them, one, three, something like that. They make like a common process, and they make common process, and then they need a part. So if schedule like this, and then part B for 2A, 1B, 1A, something like that. So before start the production, they place a part bin like this. And then without a setup, just produce continuously. So this is kind of a new technology concept. So that was now very impressive in operations management. So anyway, using whatever technique or concept, try to reduce, minimize setup time, then throughput time reduce. And when we say lean production and then lean layout for a JIT system, link operation, so link together using cell or whatever, and then work station balance and workstation capacity, the same capacity, and redesign if it's like in the case, we design and then make it flow continuously, and then try to minimize this distance, and then emphasize preventive maintenance, of course, and then make flexibility. If they produce multiple products, then reduce by increased flexibility, then reduce setup time, and reduce lot size. Definitely, JIT system use smaller size. Then to use smaller size, the focus factory network, and then such concepts need. to reduce the inventory. And then supplier partnership is important. Goal, removal of unnecessary activities, like a long distance, then it takes a long delivery distance, time, and then removal of in-plant inventory. If company use focus factory network and then they are near, then the delivery time, lead time is short, so this main company doesn't need the largest size of inventory. And then also transit inventory decrease or remove. Then improve quality and reliability using inspect at the source, then supplier, inspect and then send. And then when we say JIT production, then right amount, when they need like 100, then receive 100, then we don't, the company doesn't need an inventory. Then inventory cost low. The right time, when they need, receive whenever they need. Then without waiting time, reduce time. And then smaller size, small by small, then reduce the inventory. Then virtually no inventory achieved. So that is JIT production. And chapter 17 about maintenance and reliability. Ooh. Start hungry. Okay, this chapter not too long, maybe 20 minutes at most. Maintenance and reliability. Maintenance, everybody knows. Cost something. Maintenance. Yeah. The objective of maintenance and reliability is to maintain the capability of the system. So whenever need, the machine work. So maintenance is important. So breakdown and malfunction, cause of that, then waiting time, that is increased throughput. So maintenance is important. And maintenance, all activities involved in keeping a system's equipment in working order. So whenever they need work. And then reliability is similar. The probability that the machine will function properly for a specified time. So it's like an engine turn on, always turn on like that. Okay, maintenance management, employee involvement. So many cases, maintenance personnel. Night, what are you doing? Quiet. And then skill training. If you know, our department has a copy machine. I think this time we don't use the copy machine because I don't distribute the paper lecture notes. But regular time in a semester, maybe about 5 or 6 times the copy machine breakdown. And then often paper jam. So main problem I cannot fix, but like a paper jam, then it show instruction, open number 1, 2, and so on. So if I can do that, then I can handle myself. But many people don't know how to handle that. Then sometimes I send the copy, then when there, then it didn't make copy. That means the paper jam already, and then somebody just left like that. So I fixed myself. So if train employees, if they can handle them without waiting or ask maintenance personnel, they can handle right away. And then maybe I use reward system, and then empower, let them do it. You know, there's earlier when I taught a course, data mining course, then use a certain program, then using a computer lab, then install that. I try to install the program. Then because I don't have authorization, I couldn't do that. So I asked help desk, then personnel came and then installed. And then next class, this program was gone. So because of security, the program not in there. Then turn off the computer, then disappear, and then next time again and again. So I asked help desk, give me the authorization to install the program. No. So every time call, then later I gave up. I will not, I don't use that program. So for maintenance, maybe yeah, definitely need empowerment. And then maintenance and reliability procedure. So using this procedure like a clean, lubricate, monitor, and so on. Then result, reduce inventory, improve quality, and so on. Okay. There are 3 types of maintenance: preventive maintenance, breakdown maintenance, predictive maintenance. Preventive. We it's like you know, something a sign. Then before breakdown, change or fix and so on. That is preventive maintenance. Breakdown maintenance. When it breaks down, then fix. Predictive maintenance. I said in a semester, maybe 5 times, the copy machine problem. So 3 months is, and then 5 times or 6 times. So at most 6 times. That means every 15 days on average problem. So every 15 days, check maintenance. That is predictive maintenance. So breakdown, no prior work required when it's problem, it has problem, then fix it. But other preventive and predictive prior work, disadvantages, when it breaks down, then fix it, wait, and so on. Disadvantage. Disadvantage of two, then need kind of cost, labor cost, and the equipment cost, and so on. Time too. And then resource. This one usually doesn't need whenever it break down, then part at that time. But they using a kind of sensor and so on like that. Then yeah, here office copier whenever it break down, then fix it. And then plant and then other like big companies use preventive and predictive maintenance. And reliability. Reliability, system reliability, depending on each individual's reliability. So if improve individual reliability, then system reliability improve. So it's like each member's reliability, each like a station or stages for department. If first one's reliability is 90%, 80%, 99%, then system reliability is 71.3. So if only one member, then reliability just decrease like this, but increase the members, and then reliability drop down exponentially. So it's the same as the number of parts. Increase number of parts, then problem increase exponentially. So it's like this. So if they can reduce the process shorter, reduce unnecessary process, then improve each members reliability, then system reliability increase. And to increase repair capability, train personnel, and then adequate resource if they can have like a sensor and then equipment for fix. And then ability to establish a repair plan and then priorities. So using like a predictive or a preventive plan. And then authorization, give kind of empowerment. And then ability to identify the cause of the breakdown. You know what? The copy motion breakdown, many causes. Using not proper paper, maybe not standard part, then abuse, then misuse, and so on. So find that cause and then prevent that behavior or material. And then ability to design way to extend the MTBF, mean time between failure. Like I said, 5 times in during the time, then the mean time. So establish that kind of the plan based on that MTBF. Oh, that's all. Okay. Because this class, this chapter is, today's class is in class, so try to reduce time. unnecessary. Reduce unnecessary contact. Yeah, try. Okay, that's all. And see you next Wednesday. Next Wednesday is online only class.
There's a question.
Yes.
Can you talk a little bit about the case that you were talking about us building?
Yeah.
Just for 2 minutes.
Because this time pandemic, and then if it is like all face to face, then we can discuss a lot. So yeah. Anyway, do it. The project is making your own operations management case. So with your team member, okay, I will give you a group work, group assignment for next by next week. Yeah, good point. I forgot.
Maybe I shouldn't have said anything.
You're enemy of the other students. But anyway, you should do. Okay. By next week, discuss with your team members, the team leaders, if you can make a team meeting, or even you don't meet virtually, maybe you can use just email. So individual team members think about at least one topic. What kind of topic? Earlier semesters, team brought. I remember. The library. There is a cafeteria, right? Then regular time, long waiting lines. So because many cases, many calls during lunch and dinner time, more customer than capacity. So to solve that problem, suggestion, like increase the number of workers, not all the time, during lunch time and then dinner time. Then make it faster, then the waiting time reduce. Or using online order, or using a kiosk. Then they during not busy time, they make and then side, then just pick up. So that is good operations management case. So there is no problem, like a long waiting time, high cost, or quality problems. Then think about how can solve that problem. So when you think about the topic, don't think about the big one. I mean, already exists in a case like Amazon.com, McDonald's, and Nike, and so on. Find something near you at your work or in your life. When I was an MBA student, I took operations management. And then the instructor asked the same. Final project was making a case in operations management. At that time, I made my case using my school traffic system. So when we go out from the school, there are two entrances. Then many students came out the same time. So, and then the traffic light and the time is too short for this way. So I check the time and then capacity and so on. Then I suggested not all the time. When the time school class time end, so during the period, increase this way. The main street at that time, like at night, not many cars pass. So make it like a flexible traffic light, or make a sensor, then give longer time this way. And then one more suggestion was making the capacity of this waiting area. So that was my final project case. Then I got an A. We will talk about waiting line system later. So like that, okay? So each of you, you don't need a team meeting. Each of you, this is like an individual assignment. Think about at least one individual, because not many students in this class now at 14. So I will ask the next class one by one. And then I will decide whichever is the best for your team. So each of you think about the topic, at least one individually, okay? Then talk about this one next Wednesday when we start the class. Okay, good point. Thank you very much. Any question? Okay, see you next Wednesday on 9 on Zoom. Hello, are you there?
Hey, Dr. Kim.
Thank you. Any question?
Hey, I didn't understand what you mean by individual assignment.
Think about topic for your team
Okay.
project. You don't need a team meeting by next Wednesday. Just individually think about what can be what topic will be good. Okay. Topic operations management topic. There is problem. Maybe too long time, too much time, and then or cost high.
Okay.
Or kind of quality problems. Then what can be solution? And then if solve that problem, then what can be benefit like that?
Okay.
So don't bring the large or big topic, like a big company like Amazon, Nike, Walmart. If you can find or think about from your near or your life,
Okay.
your work.
Okay.
So don't be serious. Something like casual
Okay.
but useful.
Hmm. Okay.
Okay.
All right. Thank you.
Okay. Thank you. Any other question?
No, that's it. Thank you, Dr.
Okay.
Kim.
Good. Thank you.
Thank you, Dr. Kim.
Thank you.
Thank you, Dr. Kim. Good night.
Thank you. Good night.
Have a good night, Dr. Kim. Thank you so much.
Do you have a question?
No, not this time.
Okay. I don't know why, but your sound is very low. So it's hard to hear.
Can you hear me now?
The same.
It's the same. Okay.
Yeah.
I have no clue why, but I have no question.
Thank you, Dr. Kim. Good night.
Good night. Good night. See
Good
you.
night. Thank you.
Hello, Dr. Kim. I had one question.
Okay. What?
Yesterday I submitted my assignments, that supplement 6, but I forgot to comment my chart. So can I edit my assignment now?
Do it again and then email me.
Okay.
Okay. No problem.
Thank you. Good night.
Thank you. Bye.
Yeah, bye.